Average speed and average velocity. Why it is average speed and why it is average velocity we'll know by now, after discussing this scenario first. Means when an object is motion from here, here, so it is moving. And how to know, and this is very important, that we need to know how fast is the position of changing of an object is changing from time with respect to time. T1 the object is here, T2 it is here, T3 it is here. So the ratio of path length, that is the total distance from this just add all these to the time interval during which the motion take place from T1 to T3 say. We know it as by average speed. We denote it by V or a bar on a V. So the time interval average speed is totally speed equal to distance by time. This you need to just remember. Speed is distance by time. Path length is total distance from this to this, and time interval is still from say T3 minus T1. So if an object travels say a distance delta x in time interval delta t, the average speed in this time will simply distance by time. V will be x by t. So now the question is again, how fast the position is changing with time, right? We have to define this with the average velocity. Average velocity is the ratio of displacement. Please understand, it is displacement by time, in which this time the displacement has occurred. So average velocity will be displacement by time x by t. Average speed and average velocity, they have SI unit, meter per second, because meter per second is very small as compared to the large distances. We generally compute it in terms of kilometer per hour. And the direction is very important with respect to, or when we are talking about average velocity, because average speed, there is no concept of direction. So the direction has to be taken in certain signs. This is plus direction, this is negative direction. So we do not use the vector notation for velocity. We'll try to learn this with respect to vectors in coming discussions. Say if t equal to 0, the car start at A, it goes to B and return to C in 2 hours. So what is the total distance we have discussed? Say this is say 60, this is 40. So it is 100, the path length is 100. And the time as said 2 hours. So 100 by 2, that is this 100 kilometer, okay, 60 plus 40, and this is B, this is C. So it traveled to 60, then 40 came back. 100 is the total distance and divided by 2, which is hours, so 50 kilometer per hour. But what will be the velocity? Velocity will not take the distance, will take the displacement. So from this point, say to this point, to this point, say this was say 40 and this is 20, so 40 minus 20 is 20, and 20 by 10 is 10 kilometer per hour. And we need to understand about the sign of the velocity, because sign is very important. The sign says that the average velocity of the car is actually in the positive x direction. So now the car moves from AVCO and comes to O in 3 hours. Let us just assume that the distance is 140. That's, we say 140 by 3. That is 46.6. Now an object goes from this point and again comes to this point. It means it reaches ahead of it. So say this is 0, this is 20. So now this is minus 20. So average velocity will be 0 minus 20 by 3, say in 3 hours. So it will be negative. So average velocity of a car is in negative x direction. So the average velocity can be positive, negative, or 0. Average velocity can be positive, negative, it is 0. It can be 0. So it depends totally on the sign of the displacement. And in general, the average speed of the object can be equal, can be greater, or equal and greater than magnitude of average velocity. It will not be less. So what is the average? Average is why we are using average again and again. See, while you are moving, say from Ahmedabad to Vadodara. Now there is a very good road. There is an expressway. You went from here to here in say 80 km per hour. But at this point, from here point, there is a congestion. So you had your speed at 20. From this point to this point, oh, here also you stopped. Okay, you stopped for say 10 minutes to have lunch or your drinks. Then you reached here with some other speed. Now the total distance you traveled, you had different speeds. So we cannot have all these speeds. We need to take the average of this speed. So the average from A to say B or Ahmedabad to Vadodara, from A point to B point is 50 km per hour. But though it is not representing the actual speed you maintained during the travel, because at some time you were 20 km per hour, at some time you were 80 km per hour. So when we combine then average them, then we say that it is some 50 km per hour. I hope you got the idea. So a vehicle's start or a vehicle travels different distances with different speeds in the same direction. Find the expression for the average speed of the vehicle. Please understand, we have been asked about the average speed. So suppose the distance the travel take is, this is d1, from here to here d2, like this. Okay. Now the speed it maintained at first d1 is v1, say d2 v2, like this it goes on and on. Now what will be the total distance? d1 plus d2 till dn. So d1 plus d2, d3 and dn. You know, we don't know the distance, so we go up to dn. Total time here t1, here t2, till time tn. So let us add the time, total time, but we know the speed equal to distance by time, that is time equal to distance by speed. So in this case, this is d1 by v1. So time first t1 will be d1 by v1. Again t2 will be d2 by v2, like this it goes on. Average speed is what? Capital D by t. That is, capital D is simply the addition of all the distance, and time we just found out to be d1 by v1 plus d2 by v2 plus d3 by v3 till dn by vn. So if the vehicle starts or travels two equal distance, say d1 d2 equal to 2, means if we are here and here, this is d1 which is equal to d, this is d2 again equal to d, so both are equal to d, and see velocity v1 is maintained here, v2 is maintained here. So this is for d distance, this is for d distance. What will be the average speed? Total distance is d plus d, that is d plus d, 2d. And what is the average speed? This is t1 plus t2 in the denominator, and t can be easily obtained by d by v1 and d by v2. So we add them, d will cancel out. It will be 2v1 v2 by v1 plus v2. So average speed totally dependent on the velocity. A person walking in a straight line covers half of the distance to be traveled with a speed v0. For half of the time to complete the remaining distance, he walks with a speed v1, and for remaining half time, his speed is v2. What is the person's average speed during the complete walk? The question is like this. A person walking in a straight line, he covers half a distance, so d by 2 he covers in v0. And again we have distance of d by 2 here in the second half, but in the second half, for the half means again d by 4, right? It travels with v1 and here it travels with v2, again the distance d by 4. So you have to compute the average speed. So let us say total distance is d, so half distance is d by 2, and t1 we take as the time which is taken by first distance to cover, and we take this as 2t. Why? You'll just know. This we took as t1, this we took as t2. Now we know that the distance is average speed into time. In the first case, the speed is v0 and the distance is d by 2. So if we take t1 as the time, so simply distance traveled d by 2 will be equal to v0 into t1. So t1 can be obtained by d by 2 v0. This is the first expression for this half. Now let us go to this half. In the next one, the distance we have just computed like this, right? Now the next one, this d by 2, total d by 2 is covered in how much? We say that this is 2t. Why we take 2t? Let us take this as t, this as t. But for the computation, d by 2 will be v1 into t plus v2 into t. So this will be v1 plus v2 into t. So what we got, 2t will come here and v1 plus v2 will go down. So 2t is d by v1 plus v2. So the total time travel is, we took first half as t1, second as 2t. So t1 plus 2t. So the average speed will be what? Speed we know, distance by total time. But t1 we have just computed to d by 2 v0 here. And second time is d by v1 plus v2. We put here. And this distance is total d from here to here. All the distance is d. So just we rearrange them, d cancels out, and this is the final value.
So position time graph for motion. Motion of an object, we will represent it by position time graph. Position is where that object is lying at certain time, and at some other time where this position is. And it's a very powerful tool in order to represent and analyze different aspects of motion of an object. When we talk about motion along a straight line, we say the x-axis, the x coordinate is varying with time. So we have a xt graph. This is for x coordinate, this is for time. The slope of delta x by delta t, the slope basically, we'll talk about this. This is the slope. This theta we are talking about, and this is delta x, this is delta t. So tan theta is simply delta x by delta t, and this tan theta or slope of graph will give us the average velocity of an object for a given time interval. This theta is the angle. This is the angle between time axis. This is the time axis, and this and the line, right? This is the line and the time axis. So this xt graph we have for different types of motion. For example, you see this is a time and this is a x, means distance. Now here some distance is there, x0. With time this distance is not changing. That means the object is at rest. In this case, say it started from x0, it reached at t1 time to x1, and then at t2 time to x2. So if we take these 2 points, then this is the theta. This is theta we are talking about, and this will be, what will be the value? See, this is x2, this is x1. So x2 minus x1 is this one, and what is this? This is t2 and this is t1. So t2 minus t1 is this distance. So x2 minus x1 by t2 minus t1. This is what we are talking about. This is the theta, or you can say tan theta. Now this is accelerating, means the distance is increasing with time. Here the distance is decreasing with time. This is time, but the distance is decreasing. So it started with x0, then it came to x1 and x2. Now we want to find this theta. This will be what? This by this. This tan theta we know is perpendicular by base. This is perpendicular. What will be the value? x1 minus x2, because x1 is greater. x1 minus x2. So in this case it will be x1 minus x2 and divided by, what is the time? At x1 it was t1 and t2. So time will be same, t2 minus t1. So we see we'll get some value in negative. Why? Because this is deaccelerating. Here it is accelerating, means the distance is increasing with time. Here the distance is decreasing with time. And here this is a random motion. This is a curve. This is a curve. So here we don't have a proper uniform speed, but it is accelerating, deaccelerating. And we'll talk about how to find out the value, that is x by t, or you can say the velocity, with this kind of a graph or xt graph also. So in the first case, xt graph, as we said, that the line is parallel to time axis, so object is at rest. So slope will be what? It will be 0, because the velocity is 0. Object is at rest. In the second case, as I described you, that the motion is very uniform. That is, it has a constant velocity. So it was x2 minus x1 by t2 minus t1. This was the slope, and this slope is nothing but the velocity. This is the average velocity of an object. It is positive because it is increasing, moving in the x direction, and the slope is negative when the object has negative average value and it is moving in the negative x direction. The xt graph of any curve, instead of straight line, we call it as a non-uniform motion of an object. So motorcyclist, it travels in a straight path to a petrol pump in time 60 seconds. Now, which is at a distance of 120 meters in the east direction from his house. So see this one. This is north, south, east, west. So what is happening here is, the motorcycle travels straight path to a petrol pump in time 60 seconds. Distance is 120. So distance is say 120, and for 60 seconds it has traveled. So it has traveled like this. The next is he stays there for filling up petrol for 120 seconds. So for 120 seconds it stays, and comes back home by the same path in 90 seconds. So he comes back again to this zero distance. So it comes back in another, say 90 seconds. So after 90 seconds, he gets ready for the office. His office is on a straight way at a distance of 300 meter in a west direction from his house. So he stays there for some time and then he starts again for his office, west direction. He takes now 120 seconds. So this will be around 120 seconds, yeah, from here to here, 120 seconds. Draw the graph of position time for the motorcycle and find the average velocity for different time intervals. So the graph will be something like this. Let us see it formally. So what is happening here is he starts from 0, he goes to 120 meter in 60 seconds. Then he stays at rest for another 180 minus 60, that will be 120 seconds. 120 seconds he is at rest. Now he comes back to again 0. This is 0 line. So he comes back again and this is the time he has taken from here to here. It is 270 I guess, because it took 90 seconds to come. Then he stayed again for some time and at this time he starts for his office at this opposite direction. So time taken, or you can say take the house as the origin. We can consider the displacement in east direction, which is positive y. This is positive y and here we can take as negative y. So the position time graph you saw in the figure. So the average velocity of motorcycle in OA region, that means this region. What was that? Because delta x, it started from 0, so it reached to 120 meter. So 120 minus 0, then it started with 0 time and the time it took was 60 seconds. So 60 minus 0, that is 6 to the 12, so 2 meter per second. Now for the second, because there was no movement, so the average velocity will be 0. In the third point, from here to here, see, we take the final with the initial. So 0 minus 120, because he again came back to the house. So 0 minus 120, but he took around this much second. So we know that this is already given as 90. You can directly take as 90, but still for the sake of completion, we showed like this. This is minus 1.33 meter per second. So in the next part, that is this part, I'm talking about this part. So it was minus 300 minus 0 because we are taking in the negative direction, because we took this as a positive direction, this has negative direction. So minus 300 minus 0 by the time which is given, which is already given, so 480 minus 360, which is minus 2.5 meter per second. So plus and negative sign, what you see here, it indicates the average velocity of a motorcycle is in east direction and west direction respectively, plus for east and negative for west.